Today we are going to talk a little bit, just briefly, about transformations of exponential functions. So earlier in the semester we talked about things like x squared, and we knew how to shift them right and left by changing what was in with the x, and we also could shift it up and down, and we want to talk about how that works with an exponential function as well. So the graph that you're currently looking at is the graph of y equals 2 to the x, okay? So this is the graph of y equals 2 to the x, and this next graph I'm going to click on is y equals 3 to the x. So the red graph is 2 to the x, the purple graph is 3 to the x. Now I'm also going to show you, now I know we graphed 2 to the x and 1/2 to the x, so this is 1/2 to the x, or we could also call it 2 to the negative x, and this one is 1/3 to the x, or 3 to the negative x. Now I'd like you to kind of get an idea of this. So if you notice, all of the graphs have some similarities. So one thing I want to point out with all four of them is that they seem to intersect right here. They don't seem to, they actually do intersect at this point 0, 1. So all basic exponential functions, 2 to the whatever, 3 to the whatever, right, as long as it's to the plane x, then they're going to go through this point, as long as they're not being added to or shifted. Okay, so this is where the basic functions sit. So let's first, all right, I think I've already talked about how they behave, but if you notice, I have 2 to the x and 3 to the x. Their y values as x goes to positive infinity is positive infinity because they're like way up here, right? And their y's approach 0 on the other side when I go to negative infinity, and my 1/2 to the x, or 2 to the minus x, and my 3 to the negative x, or 1/3 to the x, do the opposite. So as x goes to negative infinity, f of x goes to positive infinity, and I can say it in calculus ways too. As x approaches positive infinity, the limit approaches 0. Okay? So just something to point out. But they do all have this point in common here, a 0, 1. So now when we were shifting quadratics, the point that we shifted was always the vertex. Now in this case, since the thing that they all have in common is this point 0, 1, that's where I try to focus my shift at. Okay? So I am going to just take these off here a little bit. Okay, so the first thing that we'll look at, okay, so this is another, so this is y equals 2 to the x again, okay, and I have it set up here so that I can manipulate it. So I have this in my Desmos, here, let me shift it over here a little bit. So I'm actually looking at the purple one there, is y equals 2 to the x plus h plus k. So the first thing I want to focus on is the h, okay? So when I manipulate h, and I have h set up to go from -5 to 5, and it's starting out here at 0. So if you notice, the h was up there in the exponent with the x. Now when the shift was with the x, it would look like x plus 2 quantities squared. But when I have it this way, it does the same thing though, as long as it's with the x. Now this graph looks a little funny when you shift it, but you want to kind of focus yourself on this 0, 1 point. So let me click on that point. So I'm going to shift this graph with h. So now my h is positive. It's kind of difficult to see here, but let me stop it here for a second. All right, so when h is, we'll stop it at 1 here. So when h is 1, okay, there we go. When h is 1, you'll notice that the point 1, 0 is actually right here, right? So when x is 1, then I get 2 to the x plus 1, and that shifts me left 1 unit, okay? So let me move this one more to 2, and then if I look at this point here, the point where it would be 1, it's back 2, right? So when I have x plus 2 as my exponent here, oops, I'm going the wrong way, here we go, then I'm shifted back 2 units, okay? So again, so this would be the graph of 2 to the x plus 2, okay? And if I shift it one more to the right, or actually I'm shifting it more and more to the left, but it looks like 2 to the x plus 3, then here is my point where it hits 1, okay? So this is where the part that we're looking for to shift. It kind of looks weird if I just look at this point here, it kind of moves around a little bit. But I'm looking at the place where, maybe I'll just put that in here. I'll just put in y equals 1, and then it'll be easier to see. Okay, so let me reanimate this now with h. So if you look, see how that's traveling across that line when it's, so these are when, let me move this over here so you can see it. So those are positive, and now these are negative, and that point is just shifting back and forth across this line, y equals 1, okay? Because that's the point it always has in common, so that's the part that I think of when I'm trying to shift it. Okay, so when I have my h is up here with my x, right? That shifts me back and forth. And so what do you think the k will do? Well, when I had like x plus 2 quantity squared plus 4, the 4 would be my k, and that moved me up and down. So let me move, I'm going to put this back to 0 here, okay? And I'm going to animate this one. So this time I'm starting at 0, and it'll go positive first. So those move up when they're positive. So it essentially, oh, it started out with negative. Sorry. So there's the positive. It keeps shifting it up, and these are the negative. They keep shifting it down. So it's the same graph. It's just shifted up and down. So this one, actually, it'll be easier to kind of follow the shift if I put this x equals 0 line in here. So let me take this one off and this one. See how that one's shifting up and down? It's like stuck on that spot. Okay, so something to notice. Let me stop this here. Let me go back to the right and left shifting. So I want to show you, it works for, so I have 2 to the x here. I also have 3 to the x here. And it also works. If I shift it back and forth, let me put my y equals 1 again. Let me animate my h again. So they both work the same way. So this is 2 to the x and 3 to the x. And if I animate here, my h, which goes up here with the x, then they both seem to move along this point. Let me, there we go. So they just shift back and forth. They both do it. And even if I add in the 1/2 to the x plus h and the 1/3 to the x plus h, they still, right, where they are, they just shift back and forth. So that is when the number is with the x in the exponent. These would be x minus, and then when we get to the other side, this is x plus. So at the end, it's x plus 5. At the other end, it's x minus 5. Okay? So let me do the same thing with my k. Let me stop animating this and move it back to 0. All right, and then I'll shift this time I'll put this other one back here, that one on, so we're going to click on this and its intersection point. So then when we shift this one up and down, we'll animate k. But they all act the same way. That one's k is negative, and this one is k is positive. Okay, so look one more time at my actual equations here. Like here, let me scroll up a little bit here. The ones I'm animating are these 4 that are here, the 3 to the x plus h. So my x plus h, right, when h is positive, that shifts me left. When h is negative, it shifts me right. When k is positive, it shifts me up. That's what it's doing right now. And when k is negative, it shifts me down. Right? I could kind of put these both in together and we'll really go crazy, but that's kind of weird, so we'll stop doing that. But I just wanted to point out that just like all the other functions that we've previously looked at, we can shift these back and forth and up and down. I'm not going to worry about anything too much more complicated than that right now. It's just more important that you just know what the general shape of the graph is like, and how we move it back and forth and up and down. I'm happy with that. Okay. If you need practice with them, if you really are like, I'm not really sure what she's talking about, then actually go to Desmos, put this in. As soon as you put the x plus h and the k in there, it'll ask you, do you want to make a slider? And you say yes. And then you can play with it until your heart is content. Okay? All right. That is the shifting of exponential functions.